Hello everyone, I am Abhishek and today we are going to solve partition equals subset sum problem and let's first jump to the problem statement what it says. So given an integer array nums, we are given a array of num integer return true if you can partition the array into two subsets such that the sum of the element in both the subset is equal or false otherwise. Which is the both the subset. Okay, we divide the nums in such a way that the sum will turn out to be equal. Nums return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal or false. So we need to divide the array into two subsets such that the sum of the first subset is equal to the sum of the second subset. In this case, we can divide like 5, 1, 5, so total is 11 and 1 is 11. So two subset we are dividing, that is 5 1 5 and another one is 11, so which we are returning true. But here we cannot divide the subset into two equal parts. What we can do it here is like we first need to calculate the sum, total sum, and we will divide that sum by 2. Then we will traverse through all the index and we will put the peak don't peak pattern over here. So peak don't peak pattern will ensure that if through the peak don't peak, if we reach the end and we got our target equals to 0, then we are able to divide the array into two equal parts. Then we can return true over there. So let's get straight to the solution here first. Like first for int n equal to nums in n nums, and first we will have int total equals 0. So total total plus equals n, and we can have int sum, our target sum equals total divided by 2. If my nums dot size, do I need to have this condition? No. Let's keep it. First let's have our recursive solution here. Though we need to have the target sum in this, and let's have helper function where I will pass the nums index number and target sum. And I will return from here, only bool value we need to return. So helper, then bool, here I will have the vector, here I will have my index idx and the target. Then here I need to check if I can take my num or not. So to take my nums, I need to check if my nums of index, I need to basically subtract this number with the target when I took this index number. So when I can take, if this num is less than equals to the target sum, then only I can take it. And when I took this thing, if I took it, then idx plus 1 and targetsum minus index. Then if we will not take it, we will have our solution as we just need to pass the target sum when we don't take the index. We are just going to the next index. After that, this is target sum minus nums, and this is 10. Then if from none of the case we got anything, at the end we will just return false. Then we will have our base case as if target sum equals 0. That means we have found out one solution, so we will return true from here. But do we need to go to the end? After that only we should return it 0. Or we can, if we found the target sum, then we are able to divide the subset into two equal parts, because we have taken the target sum as half of the total sum. So half of the total sum is there, so we are able to divide this one by two equal parts. Or do I need to go one index? Do I need to also check my index is out of bound? Then only we will return true, or this would be enough. For suppose I take this statement 5, 3, 8, 10, 11. So 11 by 2 will be 5. So if I took it 1 as 5, if I don't take any of the condition, and this I will take as 5. Then eventually it will turn out to 0, but okay, here I need to have one more condition, that if my target sum percentage 2 equals 0, that means if it's even, not target sum, if my total percentage 2 equals to 0, that means I'm checking if my total is even, then only we can have a solution for this. Control C, let's declare the target over here, target equals 0, else we can return false from here itself, because we will not get any solution for sure if it is odd. If we are actually able to divide it by 2, then only we can have our solution. Okay, so if for suppose odd number are there, even if odd number are there, even though we divide the 2 into two equal parts, we can never have any subset which sums are equal. So if odd number is there, we can return false, but if even is there, every time I will reach the 0, I will have my solution. So this turns to be correct, and if we didn't got sum at 0, but our index becomes greater than equals to nums dot idx, nums of size, then we need to return here false. And if I got anything, if I got true from here itself, if true, then I will return true. Else I have only one more case, so this only I can return. Else this part is false, this is true, any other missing case. Whenever sum will be 0, that time we can return true, but do we need to take care when any edge case I am missing or what? If I am going beyond index, for sure there is nothing, so we need to return false. But if target sum equals to 0, we can surely return true. But do I need to check nums size also, that index is at num size -1 or not? Let's run it and see if we are getting our answer correct or not. Target sum. Okay, we are getting our answer correct. Let's apply the DP over here first. Vector of vector of int DP. Here I will have my nums.size, comma, vector of int. Our target space is from this to this target, from 0 to this target, and I will initialize this with -1. Then I am passing my DP VEC TOR factor, VEC TOR factor. Okay, then I need to pass it by reference, and after my base cases are done, I will have to mark it as like index and here target. If it's not equal to -1, I need to return the same from here itself. I need to return from here. If I got the answer, I can just add my answer here, returning from this. Everything is sorted for now. Then I just need to pass my DP on both the function. I passed my DP, and yeah, that's it. Let's run it and submit it. Target targetsum. Targetsum, targetsum. Yeah, let's submit it. Hope I haven't missed any base case. Yeah, it's correct. And let's also do the same for we have done it for 0 to n. Let's track backward in the backward direction of the index from n to 0. So let's have the solution for n to 0. So for n to 0, if I'm starting it from 0, I need to start from nums.size minus 1, which is the last index. So if I start from the last index, what should my sum equals 0, but if I go beyond 0, then I need to return false. Then instead of target index plus 1, I need to do index minus 1, and here also I need to do index minus 1, and I just need to have the everything else the same. Let's run it and submit our answer. So this is the solution for 0 to n and n to 0 top down approach.